Big data refers to extremely large and complex collections of information that come from many different sources. These datasets are so massive and diverse that traditional computers and database systems cannot store or process them effectively. Big data is everywhere around us. It comes from your social media activities, online purchases, videos you watch, emails, weather sensors, and countless connected devices. This vast amount of information continues to grow exponentially every single day. When organizations collect, manage, and analyze this big data properly, they can discover powerful insights that help them make better business decisions and understand their customers much deeper. Big data is characterized by 5 important dimensions, known as the 5 V's. First, volume. This refers to the sheer scale of data. We're talking about millions of terabytes, sometimes petabytes or zettabytes of information. Second, velocity. This is how fast the data is generated and arrives at us. Modern data flows at incredible speeds from social media, transactions, and sensors in real time. Third, variety. Big data comes in many different formats. It can be structured data like spreadsheets, unstructured data like videos and images, or semi-structured data like emails. Fourth, veracity. This means accuracy and quality. Not all data is trustworthy, so we must ensure the information is reliable and consistent. Fifth, value. Ultimately, the most important V. Not all data is useful. The key is extracting the right data and turning it into meaningful business insights that actually matter. There are 4 main ways organizations process big data. Batch processing is the traditional method where large volumes of data are processed together in scheduled groups, usually during off hours like overnight. This is good for handling massive amounts of data, but there's a delay before results arrive. Real-time processing analyzes data instantly as it arrives with minimal delay. This is used for applications like fraud detection where immediate action is needed. Distributed processing spreads the computational work across multiple machines and servers located in different places. This allows processing of enormous datasets that would be impossible on a single computer. Stream processing continuously analyzes data as events flow through the system in real time. Think of it like monitoring data constantly as it streams in rather than waiting to process batches. To make sense of massive big data, we use various visualization techniques. Charts like bar charts, line graphs, and pie charts help compare different values at a glance. Geospatial maps add location information to data, showing where things are happening on a map. Heat maps use color coding to show intensity and density. Brighter colors might indicate higher values or activity. Network diagrams visualize relationships and connections between different things, like how people are connected on social media. Word clouds display text frequency, where frequently mentioned words appear larger, helping identify important topics. Scatter plots show relationships between 2 variables and help find correlations. Each visualization technique serves a different purpose and helps communicate complex big data insights in ways that humans can quickly understand. Big data is transforming multiple industries. In healthcare, doctors use big data to diagnose diseases earlier, discover new medicines, and create personalized treatment plans based on patient data. In finance, big data helps detect fraudulent transactions instantly, calculate credit scores, and execute algorithmic trading at high speeds. In retail, companies analyze customer behavior to forecast what products will sell, manage inventory efficiently, and recommend products customers might want to buy. In transportation, big data optimizes routes for delivery trucks to save time and fuel, manages entire fleets of vehicles, and predicts when equipment needs maintenance before it breaks down. These are just a few examples. Big data is being used in entertainment to recommend shows, in agriculture to improve crop yields, in sports to analyze player performance, and in virtually every major industry on the planet. Several exciting trends are shaping the future of big data. Artificial intelligence integration means machine learning algorithms are being embedded directly into big data analytics to automate decisions and uncover patterns humans might miss. Edge computing brings data processing closer to where the data is generated rather than sending it to distant data centers, reducing delays significantly. Internet of Things growth means billions of connected devices like smartwatches, home sensors, and industrial machines are constantly generating new data streams. Hybrid cloud approaches blend on-premise computing with cloud services, giving organizations flexibility in where they process data. Predictive analytics uses big data and machine learning to forecast future trends and customer behavior before it happens. Data privacy is becoming increasingly important as organizations must protect personal information and comply with strict regulations while still analyzing data. The big data field is creating exciting career opportunities. Data engineers build the infrastructure and pipelines that allow companies to collect, store, and move data efficiently across systems. Data analysts examine big data to extract meaningful insights and create reports that help business leaders make decisions. Data scientists develop sophisticated machine learning models and algorithms to predict outcomes and solve complex problems. Data architects design the overall structure and systems that store and manage enormous amounts of data. Business intelligence analysts create dashboards and visualizations that help executives understand business performance. Data governance specialists ensure data is handled securely, meets compliance requirements, and maintains high-quality standards. These careers offer competitive salaries, job security, and the opportunity to work with cutting-edge technology across every industry imaginable. Managing big data comes with significant challenges. Storage complexity involves safely storing petabytes of data in systems that won't fail. Solutions include distributed storage systems like Hadoop distributed file system that spread data across many servers. Processing speed is challenging because analyzing massive datasets takes enormous computing power. Solutions use parallel processing frameworks like Apache Spark that split work across multiple machines. Data integration is difficult because data comes from many different sources in different formats. Solutions involve ETL tools and data pipeline platforms that clean and combine data from various origins. Security and privacy is critical because data contains sensitive information that must be protected from theft and breaches. Solutions include strong encryption, access controls, and compliance frameworks that ensure data is handled legally and securely according to regulations. The big data field is experiencing explosive growth. Global data volume is expected to reach 182 zettabytes by the end of this period, which is an almost incomprehensibly large number. The big data market size is projected to exceed $200 billion in coming years, showing massive investment and growth. Over 75 billion connected Internet of Things devices are now generating constant data streams, and this number grows daily. Approximately 65% of organizations worldwide are already using or actively investigating artificial intelligence for their analytics needs. These statistics show that big data is no longer optional. It's becoming essential for business survival and competitiveness. The future of big data is clear. Data is becoming ubiquitous, everywhere, generated by everything through IoT and constant digital adoption. Processing is becoming real-time, with instant insights and decisions powered by edge computing bringing analysis closer to data sources. Analytics is becoming intelligent through AI-driven systems that autonomously discover hidden opportunities without human intervention. Big data has become business-critical. A company's data strategy now determines whether it survives or fails in competition. Security and privacy protections are essential as every organization must protect sensitive information while gaining value from it. Finally, big data careers are growing, creating unprecedented opportunities for skilled professionals who want to work with data, technology, and business transformation. Big data is not a trend. It's the foundation of modern business and technology.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.